All right, Algebra 3. Check is on. It is on. Algebra 3, this is review 7B, lessons 1 through 28. Okay, here is 2020. Okay, check, check. Check 1, 2. Check Niasi. All right. We're going to we'll go to another page for this because we need the space. All right, question number 1 says draw the necessary reference triangles and evaluate 3 cosine 60. 3 cosine 60. So that means 3 times the ratio, the cosine ratio of 60 degrees. So when you start like this. 60 degrees from the initial side to the terminal side is going to give you a reference angle. It's going to look something like that. Okay, so we need to remember our 30, 60, 90 triangle ratios. What's always opposite of 30? 1. What's the hypotenuse? 2. That means radical 3 is opposite of 60, and it's in the first quadrant, so everything is positive. All right, so we have 3 over 1 times adjacent over hypotenuse of the reference angle. What is adjacent to 60 degrees? 1. What is hypotenuse? 2. So we need 3 over 1 times 1/2, which is going to give you 3 halves. Okay? Notice that they're not coming out to nice, neat whole numbers like they have before. As you keep going further and further, they're going to give you more complex answers. All right, minus 1/2 tangent 45. Okay? I'm going to bring that minus all the way down here. Okay? All right, we've got 1/2. Right, we're going to make our coordinate plane, tangent 45. So from the initial side to the terminal side, it's 45 degrees, giving me a 45, 45, 90 reference triangle. What's opposite of 45s? 1 and 1, and hypotenuse is radical 2. We want tangent of my reference angle. Tangent is opposite over adjacent. So what's opposite of my reference angle? 1. What is adjacent to my reference angle? 1. So 1/2 times 1 is 1/2. Okay, so I have 3 halves minus 1/2. Plus 2 sine 30. Okay, I'm going to take that plus that's up there. I'm going to bring it all the way down here. Okay, we draw a coordinate plane. We make a reference angle from the initial side to the terminal side. It's 30 degrees. So a lot like what we saw before, except my reference angle is 30 this time. What's always opposite of 30? 1. Hypotenuse? 2. Opposite of 60? Radical 3. Okay? So we've got 2 over 1 times the ratio of sine 30 degrees. Sine is opposite over hypotenuse. What is opposite of 30? 1. What is hypotenuse? So we have 2 times 1/2, which is 1. But notice down here, it's 3 halves minus 1/2. So if I want 1 in terms of 2, it would be 2 over 2, right? Okay, does that make sense? I'm not showing that, but you're seeing it. So we have 3 minus 1 plus 2. 3 minus 1 is 2. 2 plus 2 is 4 halves, which is 2. Okay? Does this work for you? Okay. That's the work that needs to be shown. Can you check your work by typing all of that in your calculator in one swath? Yes, you can. You can type 3 cosine 60 minus 0.5 tangent 45 plus 2 sine 30, making sure that your calculator is in degree mode, and it should give you the number 2. Keep in mind, though, that if it gives you an irrational decimal, then that means that there is a radical in your answer somewhere, and you would have need to show all of this work either way. Okay? All right, number 2. Find the domain of the function. Starts off with x plus 5, and then down here we've got x squared plus x minus 6. So this involves both rules, right? What can I not have in a radical? A negative. So x plus 5 has to be what? Greater than or equal to 0. Okay, keep going. Subtract 5. So x must be greater than or equal to negative 5. So, no. Well, I'll explain why. X is a set of all real values such that so far x is greater than or equal to negative 5. Now, what can I not have in the denominator? No, I can't have a 0 in the denominator. So I'm going to take this and I'm going to factor it and find out what values for x will cause the denominator to equal 0. So x and x, I've got plus minus, which means it has to be plus minus, right? Things that multiply, so it should be what, 3 and 2, which means x cannot equal negative 3, and x cannot equal 2. Now, the reason that none of those are listed down here, why aren't any of those listed? Because x is going to be greater than or equal to negative 3, or sorry, negative 5. It also does need to have listed that it cannot be 2 or negative 3. It should have listed that. It didn't in the answer key. It should have. Okay, you need those. The reason why you need those is because 2 and negative 3 are both greater than negative 5. Okay, so it's everything greater than or equal to negative 5 except 2 and negative 3. Does that make sense? Okay. All together in here. Okay, by now we should be getting used to this right here. Okay, I'm not necessarily concerned about the brackets, but we should be getting used to the labeling on this. Okay. All right, ready for 3? Okay. 3. Let's see. F of x equals 4 sine x. Find f of 330. Do not use a calculator. Basically, what we're saying is if we want 4 sine x and find f of 330 degrees, what we're saying is what is 4 sine 330? Okay, so we come in here, right? 330 degrees is going to go all the way around like this, right? But it's going to be 30 degrees shy of 360 degrees. Okay, so that means this is negative 1, this is radical 3, and that's 2. Correct? Okay, so sine, based upon the reference angle, is opposite over hypotenuse. So we take 4 over 1 times negative 1 over 2, which is negative 4 over 2, which is negative 2. And that's how I show the work, even though I can probably type that in my calculator and get negative 2. But you can check it with your calculator, yes. Okay? You do have to show your work. Okay? Because if you notice in here, it says do not use a calculator, meaning that you should be able to show your work for this. Okay? Okay, because notice that it has a radical 3 involved in the question, right? So if they had said instead of sine, they'd wanted the cosine of this, you wouldn't have gotten a nice, neat number. They can just as easily give you cosine on the test. Okay, so you need to be able to do it without a graphing calculator. Okay? All right. And that came out to the right answer? Great. 4. 4, evaluate 8 factorial over 4 factorial, 4 factorial. Okay? It says don't use a graphing calculator. So this is 8 times 7 times 6 times 5 times 5 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1, 4 times 3 times 2 times 1 times that, right? Right, we're familiar with factorials. All right, we can cancel out all of these off the end. Okay, let's see. Yeah, 2 and 3 would get rid of the 6. 1 doesn't matter, right, because dividing by 1 isn't going to change anything. So we really have 8 times 7 times 5 divided by 4 is what it simplifies down to. So you got 56 times 5 divided by 4. What's that? And you might even be able to, I'm wondering if you, I don't know if it'll let you do this or not, But if you can simplify 8 divided by 4, 8 divided by 4 would be 2, right? So let me see if I'm wrong here. But if I go ahead and I simplify that to 2, that would be 2 times 7 times 5, right? So I would get 70 in that case. Is the answer 70? Yeah. Okay. So you see how we can do that. Okay, where this equals 2. Okay, that's where I grabbed 2 from. And then I'm just left with 7 times 5 times 2, which is easier to do. Okay? Are we good here? All right. 5, and again, you can always check your work with a graphing calculator, but you need to show your work without. All right, 5. Okay, it gives you x squared plus x, but it wants you to find f of x plus h. All that means is everywhere where there is an x here, you're going to put in a set of parentheses like this. Okay? And then inside that set of parentheses, you're going to put x plus h. And then because this is x plus h squared, you FOIL that. Okay, so it becomes x plus h times x plus h plus x plus h. Okay, you FOIL this, you get x squared xh plus xh plus h squared plus x plus h. Okay, combine like terms, right? You get x squared plus 2xh plus h squared plus x plus h. Final answer. Make sense? Excellent. Again, you'll have the video in this document to work from later. 6 is one. It's a word problem, so a lot of people struggle with things like this. 15 years ago, Phil. All right, so we want to start off with Phil minus 15. Okay, 15 years ago. He's going to be 15 years younger. 15 years ago, Phil was twice as old as Daryl was then. So P minus 15 is 2 times Daryl minus 15. Does that make sense? All right. If Phil is twice as old, then we have to double Daryl's age to get it to be equal to Phil's age. Okay? So if they're not equal, we have to make them equal. All right. 3 years from now, Daryl will be as old as Phil was 4 years ago. Aren't these fun? All right. 3 years from now. So that would be Daryl plus 3. Okay? Will be as old. All right. Well, that would be the same age as, right? If I'm going to be the same age as or as old as you are, okay, as old as Phil was 4 years ago, well, that's going to be P minus 4. Now, what you guys can do and what you're probably prone to do is if I can get P and D on the same side of both of those equations, I can matrix. Okay? So, for instance, up here, we have P minus 15 equals 2D minus 30. Okay? Subtract 2D, add 15. Okay, and I'm going to get P minus 2D equals, what, negative 15? Okay, for the first equation. Does that make sense? Okay? Subtract P here, subtract P here. I got negative P plus D, subtract 3 equals negative 7. All right, so what you're going to show me after all of that is RREF, and you're going to have 1, negative 2, negative 15. You're going to have negative 1, positive 1, negative 7, and you're going to show me, you know, you're probably going to get what, 1, 0, 0, 1, and then your numbers there and there for P and D. Right? Sorry, do I need to scroll that up a little bit? Let's see, does anybody want to work that matrix out and make sure that that works? comes out to the right answer. Should be a 2 by 3 matrix. Do you want me to do it? Okay, David's got it. 1, -2, -15, -1, 1, -7. On a 2 by 3. RREF, matrix A, hit enter. I don't know. Is that it? 29? 29 and 22? 29P, 22D? Okay, so it worked. There are other ways to solve it, but I figure that's the way that most of you are going to lean on. Okay? Can I move on? No? Some of you are leaning on that. I guess I could actually look at what I have for answers here. Yep. Okay, continuing on. 7 has an A and B, I believe. Has a C as well. All right, 7A. Okay, we're looking at some log questions. We got log x 2 equals 1/2. All right, I'm going to turn this into exponential form by moving the x up, making 1/2 the exponent, and making 2 the solution. Okay? This, anytime I'm taking something to the 1/2, is the same as the square root of that thing. Okay, so the square root of x equals 2. How do I get rid of a square root? Square both sides. All right, so that cancels out the square root, and we get x equals 4. That makes sense? Yes. Okay. B, we got log base 3 to the 1/3 equals x. Again, convert it to exponential form. The 3 comes up, x becomes the exponent, 1/3 becomes the solution. Okay? Now, I want to get this 3 right here in the same position that my 3 is on the left. All right? That is 1/3 to the first. But if I were to move it above the division bar, make it a numerator, what happens to its exponent? Becomes negative. All right? So now I can see that x is in the same position as -1. Does that make sense? Okay? Let's come down and work out question C. Come on. There you go. C. Let's see. So we've got log base 2x equals -3. Okay, exponential form, 2 to the -3rd equals x. Right? I've got 2 to a negative exponent. I want to change that to 2 with a positive exponent, so I'm going to drop it below the division bar. Okay, now that it's below the division bar, I can simplify it. 2 to the 3rd is 8, so 1/8 equals x. Okay, do those 3 answers make sense? Do we know how to take a log form and convert it to exponential form? Does anybody need to see a quick example of like, hey, how does that always work? For instance, let's use just if I have log x, y equals z. All right, the exponential form is always going to be x to the z equals y. Okay, all you're doing is changing the location. Okay? The bottom number moves up and the other 2 numbers switch places. Okay? All right, what was that? 7? We're on 8. All right. You guys have seen questions like this about 100 times. All right, so we're solving for L, but we start off with 3s equals 3 over 2t. This one's just a little bit more complicated than what you've worked with. 8d over L minus 3m over d. Okay, so you have a couple options here. I would go ahead and distribute the 3 to the numerator and 2t to the denominators. Okay, that's going to give, what is that? We have 3s equals, what is that, 24d minus 9m. This is going to be 2TL over 2 TD. Okay? The only thing left is that in order to actually combine these, I need a common denominator. So I'm going to multiply this side by d over d and this side by L over L. Does that work for you guys? Okay, so that's going to give me 24d squared minus 9ml all over 2 TDL. Okay? Now I want to get rid of the denominator, so I multiply it on both sides. So 2 TDL, 2 TDL. Okay, and because I'm multiplying, this actually comes out to be, here, let me give myself some more space. 6 TDLS equals 24d squared minus 9ml. Now, this is at the point where it's important what I'm solving for. In this question, I'm solving for L. So I'm going to move the set that has the L in it over to the left-hand side to join up with the other value that has the L in it. Okay? So I'm going to add 9ml to both sides. Okay? That's going to give me 6 TDLS plus 9ml equals 24 d squared, right? Factor out the L. Okay? Leaving me with 6 TDS plus 9m equals 24 d squared. Now that L has been factored out, I can move the rest of it over to the other side by division. Okay, so divide by 6 TDS plus 9m. Divide by 6 TDS plus 9m. Almost made a mistake there. All right, and it looks like all of that, out of all of this right here, right, I do want to look at what can be factored out of that, and it looks like a 3 can be factored out, right, leaving me with, I believe, 8d squared over 2 TDS plus 3m. Is that the final answer? Okay. So a lot of steps there. It is stuff that you've seen before. It's not a different process. It might be a touch more complicated with some of the things that they're giving you with giving you a multiplying by a fraction on the outside. But other than that, all the same steps. Okay. What was that, 8? We're ready for 9. Everybody's favorite, working with negative square roots and I and all of that stuff. 9. Okay. Square root of negative 16 plus square root of 9, square root of negative 9, square root of negative 9, minus square root of negative 5, square root of 5. All right, I'm going to, for now, for sake of space, I'm going to ignore the denominator at this point. Okay? We'll come back to it here in a little bit. The first thing I want to do is I want to simplify each set. So this right here, square root of negative 16. What can I take out of there first? And I, leaving me with I square root of 16. Square root of 16 will simplify to 4. So I get 4i. Not a nice thing to call somebody, but accurate in this representation. All right? All right. Here, what can I take out of those negative 9s? 2i. So we got I, radical 9, radical 9, radical 9, right? Is 9 a perfect square? Yes. So what are all of those square root of 9s? 3s. So I really have I squared times 3 times 3 times 3. And what is I squared, or double I? So I really have negative 1 times 3 times 3 times 3. So I've got negative 3 times 3 times 3. Or negative, what, 27? Negative 27. Okay? So far, we've got a negative 27. And Make sure that we have that plus there, okay? All right, finally, and we're going to go ahead and bring this minus down to there, okay? We can take out an I and get square root of 5 times square root of 5. What's square root of 5 times square root of 5? 5, so we get 5I, right? Okay? All right, so I got 4I plus negative 27 minus 5I. My like terms are 4I and negative 5I, right? So I have negative 27 minus I, right? Over, now we get back to our denominator, which is 2 minus 3I cubed, okay? This is a long question now that I'm looking at it. Okay, so let's look at just that denominator there, 2 minus 3I. Okay, 2 of those i's become what? So 2 minus 3 times negative 1 times I. Negative 3 times negative 1? Positive 3. So that's actually 2 plus 3I, correct? Yes? Okay, so I have negative 27 minus I over 2 plus I. Oh, it's good to be all done, isn't it? Except we're not. What do we have to do? Multiply by the conjugate. Just keeps going. Okay, now what do I do here? FOIL. Okay, all right, negative 27 times 2. Negative 54. Negative 27 times negative 3I. That's going to be positive. Negative 27, or sorry, just 27 times 3. 81I, right? Okay, negative I times 2. Negative 2I. Okay, and negative I times negative 3I. Well, that would be what? Positive 3I squared? But positive 3 times I squared is negative 3. All right, combine like terms here. We got negative 54 minus 3 is going to be negative 57. We got positive 81I minus 2. It would be plus 79I, correct? Okay. All right, so that's my numerator. Now let's go to the denominator. 2 times 2 is 4. Do we need the inner two terms? No. All right. 3I times negative 3I. Well, that would be negative 9I squared. What's negative 9 times negative 1? Positive 9, right? So I'm going to get 4 plus 9, which is 13. Now, before I'm all done, I want to be sure that I can't simplify that, because a bunch of you get here and just stop and don't ever try to reduce the fraction if it's reducible. Does negative 57, does it divide by 13, or does it at least simplify? It doesn't simplify. What about 79 divided by 13? Does it simplify? All right. Then I can say this is my final answer. Was that the right answer? Okay. But make sure and see if it will reduce. Okay? All right. That's 9. Let's see. 10. All right, I gotta look in. You should get something that's gonna look like this. Okay, and you're gonna give me an XY. Okay, and I should see something like, negative 3, negative 1/5, negative 2, negative 1/4, negative 1, negative 1/3, 0 is negative 1/2, 1 is negative 1, 2 is infinity, or I should say error in your calculator, 3 is 1, 4 is 1/2, something like that. Okay. Huh?
How many of those do you want? Don't you want like 40 or something?
I mean, all you're doing is getting them out of the table of your graphing calculator, right? Okay? So can you go from -3 to 3? You're just copying a table. You're not actually even plugging them in. Right? Okay, so I don't think I'm being extreme here by saying go from -3 to 3.
Yeah, I think this is tough.
Okay.
Wait, okay, that infinity sign.
It's going to be error in your calculator. Okay, but you need to put an infinity sign there. Okay, because it is what we would call the asymptote. Okay, it's that line right there. Okay. All right, 11. Okay, Machiavelli can mow the lawn in 30 minutes. Carl can mow the lawn in 20 minutes. Machiavelli works for 10 minutes before Carl begins to help. How long will it take them to work together? Okay. Machiavelli, one job, 30 minutes, right? Okay. Carl, one job, 20 minutes. Rate times time plus rate times time equals jobs. Okay. Let's see. Machiavelli works for 10 minutes. So his is time plus 10. Okay. Plus his, which is just t. And we want to know it's one job, right? Rate times time plus rate times time equals jobs. Okay. So 1/30th t plus 1/3 plus 1/20th t equals 1. Okay. These two terms right here are things that can be added, but they need a common denominator, which would be what, 60? Yep. All right, so that would be what? 2/60ths t plus 3/60ths t, right? We're going to subtract 1/3 from 1, which is going to be what, 2/3? That should be something that we can just think about and get right, correct? 1 minus 1/3 is going to leave me with a remainder of 2/3. Yes. Okay. All right. If you have to really, really think about it, you can. All right. That's going to give me what, 5/60ths? All right. 5/60ths t, which is something that can probably reduce to what, 1/12? All right. So that's going to be 1/12 t equals 2/3. Right. So we're going to come over here. 2/3. We're going to multiply that by what? 12. 12 over 1. All right, that's going to give me what? 24 over 3. 8. 8 what? Minutes, because everything has been in minutes up to this point. Now, if they threw in minutes and hours, we would need to get it into a common time term. Okay? But everything they gave me was in minutes, so our answer is in minutes. Does that make sense? Okay? The very first thing you need to establish when working these questions is what kind of formula are you working with? Okay? Is it rate times workers times time equals jobs, or is it rate times time plus rate times time equals jobs? All right. Let's see. Number 12 is this one that you want to see. Okay. Okay, so I'm just going to give you the answer. I mean, is the answer listed? Is it shown in there? Okay. 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 So we know that MN is going to be congruent to ON because a midpoint divides the segment into two congruent segments. Okay. Let's see. Then we want angle, I think it's MNL, is congruent to angle ONP. And what we're going to say is vertical angles are congruent. Once I have that, I can say that angle L is congruent to angle P. Because if I have two angles congruent to two angles in a triangle, then I know that the third angle is congruent. It's called the third angle theorem. Okay, now I can say the two triangles are congruent. Okay, I'm not listing that there, but it's angle, 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 side congruency postulate. Now I can say that the pieces that I'm looking for are congruent. LM is congruent PO, because now that I've proven that the two triangles are congruent, their corresponding parts of congruent triangles are congruent. Does that make sense? Okay. Yeah, bud. 13. I've got like 4 minutes. I'm not going to get through all of this. What's that? It skipped? Oh, it was good. Okay, so you think what? Probably. Does the other video cover, it covers everything? Oh, good. So whatever we don't get covered today is fine, right? We're fine? Okay. Now, okay, does it cover question 15? It doesn't cover question 15. All right, so let's cover 15 here and call it, okay? So 13x 5n plus 2 minus 26 x to the 3n plus 1. A lot of us are really struggling with these. Okay, so 13 is a prime number. 13 is just 13. You can't break it down to anything less than 13. So we got 13 times x to the 5n. That's x to the n 5 times. And that x plus 2, that's x and x, right? This is 13x to the 5n plus 2. Does that make sense? All right, now negative 26, that is 2 and 13, right? And x to the n 3 times. And just a remaining x. So now what I'm looking for is everything that shows up in both sets. Both have a 13. So we can take this 13 and put it out here. They both have 3 of these. Right? So that's x to the 3n. They both have 1 of these. So plus 1. What's left, okay, is x to the n plus 2. Hold on. Nope. Because, oh, I circled the wrong one. Okay, this should be still x to the n, right? We'll get rid of that one. Okay? All right, so we have x to the n. Hold on, what do we have left? We should have x to the what? The 2n, right? Left in here. Plus 1. All right, minus 2. That's it, right? Everything else over here has been taken. Does that work? We got it? Okay. Yeah, I'll still send you this video. Okay. All right, I'm going to call it there. We covered 13 questions out of 20, so you should find the other 7 in the other video. I'll send you both videos, okay, and this document. Taking it tomorrow.